Assalamu alaikum. Welcome our dear students and part 4 of the lesson electrostatics, which is the last part. At the end of this part, you will be able to explain how to calculate the quantity of electric charge. Now, proton and electron are very tiny particles having equal magnitude of charge called elementary charge E. The charge of proton is plus E, while the charge of electron is minus E, with E equal 1.6 times 10 power minus 19 C. But what do we mean by C? C is the coulomb, which is the SI unit of electric charge. In a neutral atom, number of protons equal number of electrons. Its net charge is Q equal 0 coulomb. Now, if an atom loses 1 electron, its charge Q equal plus E. If an atom loses 2 electrons, its charge Q equal plus 2E. If an atom loses 3 electrons, its charge Q equal plus 3E. If the atom loses n electrons, so the charge of the atom is the number of lost electrons multiplied by the elementary charge, which is Q equal plus n multiplied by E. Now, if an atom gains 1 electron, its charge Q equal minus E. If an atom gains 2 electrons, its charge equal Q equal minus 2E. We mean by Q equal minus 2E, Q equal minus 2 multiplied by E. And if an atom finally gains 3 electrons, its charge will be Q equal minus 3E. So, the number n of excess or deficit of electrons in an object determine the quantity of charge Q of the charged object. Absolute value Q equal n multiplied by E, with E elementary charge equal 1.6 times 10 power minus 19 coulomb. If Q is smaller than 0, that's mean excess of electrons, Q equal minus NE. And if Q greater than 0, which is positive, deficit of electrons, Q equal plus N multiplied by E. Now, let's solve application 1 for this section. Consider two bodies A and B carry respectively the charges QA equal 4 times 10 power minus 10 coulomb and QB equal minus 8 times 10 power minus 8 coulomb. The first question for this application is to specify which one has excess and which one has deficit of electrons. The answer will be, here we have QA is a positive number which is greater than 0. So A has a deficit of electrons, while QB is a negative, smaller than 0, so B has an excess of electrons. Now the part 2 of this application, to calculate the number of electrons that form the charge of each one. The answer will be like this. QA, we're going to apply the formula QA equal NA multiplied by E. So NA, it will be QA over E. So we're going to substitute the numbers, which is 4 times 10 power minus 10 over 1.6 times 10 power minus 19. The answer will be 6.4 times 10 power 9 electrons in deficit. And for QB, NB equal QB over E. So we're going to also substitute the numbers 8 times 10 power minus 8 coulomb over 1.6 times 10 power minus 19. The answer will be 5 times 10 power 11 electrons in excess. And be careful about the absolute value in this case. Here, we insert an absolute value for each one in order to prevent the negative value for NA and B, because the number of electrons, it can be negative. Now, let's define the conservation of electric charge. Charge is neither created nor destroyed, as we have explained before. It is only transferred from one object to another. So charge is conserved. During electrification, all charges are transferred or distributed between the two objects. So, according to the conservation of the charge, the expression will be Q before equal Q after. That's mean QA plus QB equal Q prime A plus Q prime B, where QA and QB are the charges of A and B before friction, contact, or induction. Q prime A and Q prime B are the charges of A and B after friction, contact, or induction. Now, here we have a special case of conservation of electric charge for identical conductors. After contact, the charge is distributed equally on both conductors, so the expression will be finally Q prime A equal Q prime B equal QA plus QB divided by 2. Now, how can we find the number of transferred electrons between two conductors? It will be like this. N transfer is equal to N prime A minus NA but in an absolute value, or N prime B minus NB. And here we insert the absolute value to prevent the negative number for N, because it is a number of electrons and it can't be a negative. Or we can say that the number of transferred electrons between the two objects is N transfer equal absolute value Q prime A minus QA over B over E, or N transfer equal Q prime B minus QB absolute value over E. Now let's solve the application 2. Two metallic balls of respective charges Q1 equal minus 3 microcoulomb and Q2 equal 5 microcoulomb. Now we are placed on contact. Both of these balls are placed in contact, and if the charge of the first one after contact becomes Q prime 1 equal 1.5 microcoulomb. The first question: determine the new charge Q prime 2 acquired by the second ball after contact. The answer will be like this. By applying the law of conservation of charge, Q1 plus Q2 equal Q prime 1 plus Q prime 2. So Q prime 2, it will be Q1 plus Q2 minus Q prime 1, and we're gonna substitute the values instead of each one. So finally Q prime 2 will be 0.5 microcoulomb. Now the second part is to specify the direction of transfer of electrons between the two balls. The answer is from the first ball to the second one. Why? Because since the first ball is initially negative, it has the tendency to lose electrons, and the second one is positive, so it has the tendency to gain electrons during contact. The third part is to calculate the number of transferred electrons between them, such that every 1 microcoulomb is 10 power minus 6 coulomb. The answer will be like this. We're going to apply the formula or the expression N transfer equal Q prime 1 minus Q1 over E in an absolute value, and we're going to substitute the values instead of each one. So the final answer will be 2.8128 times 10 power 13 electrons. So this is the number of transferred electrons between these two balls. Now, let's take another application. Application 3, we have three identical spheres A, B, and C carry the charges QA equal Q, QB equal minus 2Q, and QC equal 2 times 10 power minus 6 coulomb. The first question, we put A and B in contact. The question is, calculate at electric equilibrium the charges Q prime A and Q prime B after contact in terms of Q. The answer will be like this. After applying the law of conservation of charge between A and B, QA plus QB equal Q prime A plus Q prime B. This is the conservation of electric charge. So the two spheres are identical. Be careful about this one. So the special case, it will be Q prime A equal Q prime B equal QA plus QB over 2. And substitute the value instead of each one, in order to have the answer in terms of Q, it will be minus Q over 2 Coulomb. The second part, now we approach the sphere B of charge Q prime B to the sphere C. We observe that B and C attracts and touch each other, then they stop interacting. So the question is, determine the value of Q. The answer is, after contact, B and C stop interacting, so B and C become neutral. Of final charges 0. So Q double prime B equal Q prime C equal to 0 Coulomb. Applying the law of conservation of charge here between B and C, Q prime B plus QC equal Q double prime B plus Q prime C. The two spheres B and C are identical. Be careful about this one. So Q double prime B is equal to Q prime C equal Q prime B plus QC over 2. And it is equal to 0. And substitute the expression of each one instead of this unknown value. So finally, we have Q equal 4 times 10 power minus 6 Coulomb. Now in the second part, 2.2, deduce the value of Q prime A, Q prime B, QA, and QB. The answer is QA is equal to Q. As we see in the given, it will be 4 times 10 power minus 6 Coulomb, and the QB equal minus 2Q. Only substitute the value of Q instead of Q here. So QB will be minus 8 times 10 power minus 6 Coulomb. And in order to find a Q prime A and the Q prime B, they are identical, which is equal to minus Q over 2. The final answer will be minus 2 times 10 power minus 6 Coulomb. Let's make a quick summary about the whole lesson. We have three types of electrification. By friction, the two rubbed objects become charged with opposite signs. By induction, without grounding, the object is polarized, and with grounding, the object is charged. And finally, we have by contact, the two objects become charged with same signs. And electroscope, we have charged object, the leaves repel by induction or by conduction, and if the electroscope approach to it a neutral object, the leaves remain in their initial positions. And quantity of charge, a charged object, Q equal N times E, and if the object is a neutral one, Q equal to 0 Coulomb. And finally, the conservation of charge, we have the formula or the expression Q before equal Q after, that's meaning QA plus QB equal Q prime A plus Q prime B. And we have a special case in an identical objects, Q prime A equal Q prime B equal QA plus QB over 2. This is the end of part 4 and of the lesson. Goodbye and good luck.